Okay. Hmm. Uh, what exactly the use of the NumPy, Rajesh?
I didn't attend the class yesterday, so it could be probably.
Okay. Yeah. Numerical Python. So there we can work with, so some kind of mathematical operation a little bit faster than the Python programming language. Okay.
Okay.
Let me go for open my. Okay, fine. Okay. Let me open Anaconda Navigator. So let's refresh for yesterday's class again. We can collect some new information regarding about numerical Python. Clear? Let's just launch Jupyter Notebook. And you just selected whatever you wanted. We just go for your specific folder, and we are the stats, right? I think we are talking about this is what I explained in yesterday's class, right? Okay, so just to recap it. Just recap it. Okay, so you know what, so NumPy is the one of the third-party package. It's mainly used for to do some kind of numerical operations that we can import with the help of the import keyword, and we can rename with the as keyword. Okay, next we can try to print it what information is there inside of the NumPy. So we have a lot of functionalities we have it, but it's impossible to remember, right? Just to know where to use it and how to use it. Okay, and basically the NumPy, which is following the n-dimensional array data structure. So we can try to be go for creating the arrays or matrices or in a one-dimensional, two-dimensional, and in a multi-dimensional way. Okay, so here I just created here one-dimensional matrix. So I just given a one particular list of element as an input for the array function, then it was creating the one-dimensional array. Meanwhile, we can creating the two-dimensional array, and we can creating the three-dimensional array with help of the array function. Meanwhile, we can creating the array with help of the arrange function. There we can creating the some range of elements from one start element to stop minus elements. Okay, and we can reshape your array function or array. Here we have approximately 6 elements are there, right? These 6 elements we can reshape into 2 rows and 3 columns with help of the reshape method. This is the way, if we have one particular matrix, that we can change the shape of that particular matrix. Clear? So this is the way we can use the arrange function and reshape function. And here we have a linspace. The linspace will help you to divide your number of elements in equal part actually. Okay, for example, in between 10 to 50, I want the 10 elements, then equally we can split it. Is it clear? This is the way the linspace can help you a lot. So meanwhile, we can do some kind of operations like addition and subtraction, and we've seen that a small difference between the list data type and array data type. Clear? Meanwhile, we can creating the some random integers from one particular element to another particular element, some range of element. I mean, for example, I want the 10 elements in the range of 18 to 45, but randomly you have to be selected. For that one, we can use the randint function. So like this, we have a lot of functions are there. Those things also will be looked for one time. Okay. So I can share you this document. You don't worry about, guys. This is the numerical Python. So it's just explain about what exactly numerical Python, what I explained in yesterday class. Same thing will be there here as well. Okay. So here we can able to go for creating the one-dimensional array, or else no two-dimensional array and multi-dimensional array that we already seen it. So arrange function, array function, and linspace function, we already seen it, right? Now we can creating this some kind of random elements. So we just go to this particular function, guys, random.rand. So this is the function will help you to just generating the some random elements in between 0 to 1. So maximum we can generate it only 1 or 0.999 something else, and in between the 0 to 1, so we can generating any number of elements when I'm giving this particular function. Okay, is it clear my point? So here we selected or we generating the 7 elements. For example, if the same program we can execute one more time with a different number, now I can just give you 10 here, then it was generating the 10 elements. Okay, this but here that this 10 elements, which the range is, it's a 0 to 1 only, not more than the 1, not less than the 1. That you should remember it. For example, we got a one particular requirement, you want to generating some kind of random numbers, but the range it could be 0 to 1 only, then we can use this particular function. Clear? Is there any question, guys?
Here.
Yeah, this is basically mostly we can use it in a data science. Actually, that's what this function I was listed here. Okay, but whatever the function we seen it here, this you don't need to remember this whole thing, but at least we can remember what I mentioned here. So for example, you would like to go for generating the, okay, 2 rows and 4 columns with range of 0 to 1. So that meaning you understood or not? So previously we generally generating only one dimensional array, but with help of the random.rand, I would like to go for generating the 2-dimensional array, but which is having the 2 rows. This is my row 1 and this is my row 2, and which is having the 4 columns, right? So this is my column 1, column 2, column 3, and column 4, right? So this is the way 2 into 4, totally 8 elements we can generating, but this 8 element, the shape is, it's a 2 by 4. Clear? But the range of elements are, it's a 0 to 1 only, not more than 1, not less than 1. Any questions?
What should we do if we want more than 0 or 1?
So
Like 1.x.
simply you just multiply it. For example, I want the range between 0 to, okay, 0 to 10. Then you can simply multiply with 0 to 10. Then we can able to get this kind of range of elements. Clear or not?
Okay,
See, by
so
default it's a 1. By default it's a multiplication of 1. Okay. For example, I want the range between the, okay, and so previously I generated the integer elements, but now with the floating elements also I wanted. That's a good question actually. But range of elements I wanted. Simply what we can do, for example, in between 5 to, okay, in between in between so if we want to generate some range of elements from 0 to some elements, we can do it actually. Okay, for example, 1 plus, okay, so which is generating the range of elements from 1 to 10 or 11. For example, I want to generate the elements from in between 7 to, okay, 7 plus, and for example in between 7 to 20, this kind of range of elements I wanted, but it could be float data type. Then we just go ahead actually. So is there any element is the less than the 7? No, right? Is there any element is the more than the 20? Oh, sorry, not more than 20. It's a 20 plus 7, 27. Okay. Is there an element is the more than 27?
no.
So here, whatever the number you're going to be multiplying and whatever the number you are added, okay, this is the max element. Okay, 27 is the max element. So none of the element is not more than or equal to 27. But there could be element, it could be, okay, in between 7 to 27. But I want it 7 to 20. Then what we can do? Simply we can multiply with 13. Then 7 to 30 range only we can generate it. Is there an element more than the 20 and is there an element less than the 7? No, right? So this is the way we can able to generate the elements, some range of elements at a fractional value also. Clear?
Here.
Guys, can you please meet your systems? Srujan, I'm getting a little sound from your end, so just muted you. And if you want to talk anything, you can. Okay, once you can mute your system and you can talk. Okay. Yep. I hope you understood what exactly the rand function is doing, which is just generating the random elements, but it's a floating fractional numbers, right? But the default it's a 0 to 1 only. But if you want to generating some range of elements, we just add and multiply with that particular range. Now I want to be generating the three-dimensional matrix. The matrix which is having the four rows, or sorry, four matrices. This is one matrix, this is one matrix, this is one matrix, and this is one matrix. So I have the four matrix. For each matrix, I should have the two rows only. This is my row one, and this is my row two, and this is my row one, and this is my row two of the second matrix. This is my row one of the third matrix. This is my row two of the third matrix. This is my row one of the fourth matrix. This is row two of the fourth matrix, right? For each matrix, or for each row which we have the for each matrix which we have the three columns. So this is a column one, and this is column two, and this could be a column three, right? So this is the way we can able to go for generating the three-dimensional array also. If you want to know what exactly the shape of it, we can just go ahead with shape. The shape, it could be a 4 and 2 and 3, but now I just want to find the dimension. We just go ahead and the IM, right? So here we can able to get the output is it's a 3. So 3 indicating that it's a three-dimensional. Is it clear, my point? Is it clear or not? 3 indicating that it's a three-dimensional, and this could be the shape indicating that how many rows and how many columns and how many matrices which was generated here. I hope it clear, but default it's a 0 to 1 only. So none of the element is not more than the 1, and none of the element is not less than the 0. I hope it's clear. So this is the way we can able to go for generating the random integers, random fractional numbers also. Okay. Now let's do, we can able to go for create one particular array. That array I want to be storing into the file. That's my assumption. For example, you have some data. Okay, you have some data. So the data which is an array, this is array I want to be stored into file format. Okay, simply we can generating one array. So this is the array is, it's a three-dimensional array, and which we have the two matrix, and each matrix which we have the two rows, and each row which we have the four columns, right? So it's a 2 2 4, 2 2 4. That could be the shape of it. This shape of array I would like to be stored in one particular file. Then I just open the file. You already know that with the help of the open function we can open the any file, and this could be my file name, and this is the file is write binary. So you're going to be writing the data into the binary file format. I think in a file concept I just explain only text file format, right? We can open the file and we can write only text, right? But now I want to be write some kind of binary data. We just give you WB, which means write binary file. So this is the name of the file, and what I would like to go for store, this is the array I would like to be writing into this particular file, and with help of the save function np dot save, and you're going to be saving this particular file, and the name of the file is array, and I'm holding into the data is, this is the array I'm holding into this particular file. Is it clear? Then after you can close with help of the close function. I hope it's clear. Now I want to be read it. I want to read this array file. I want to read this array file with help of the again open function, but by the time of reading we just use that rb means reading the binary file. So here array is arr is the binary file, and we are going to be opening the file in rb mode, so that we can open this particular read mode. Once if you open the file in read mode, we can use the load function. With help of the load function, we can load the, or we can read the entire array from that particular file, and we can save this data into a new variable, and that one only you are printing. You're not printing this array, guys. This is the array we are writing into this particular file, and After that, you close it, that particular file. Again, you open the file and in the read mode, and we are loading the data, whatever the data we have it inside of that particular file, and we are printing that one. This is the way we can save the file, and we can save the array into the file, as well as we can read the data from the file. Is it clear? Is it clear or not?
Clear. So the write plus and read plus functions work same as in text files, the same concept for binary files as well.
See, actually here we don't have any kind of read and write functions over here. Okay, we have save and load. Save is nothing but writing, load is nothing but reading. That's it.
Gotcha.
Srilekha, Rajesh, Pavani, Suman, Vamshi, Jay, Srujan. Okay. Okay, I hope you understood this particular concept, right? Yep.
Yep.
Now, I want to be, I just want to go for creating the zeros matrix. So here, np dot zeros is the method. With help of this method, we can generating the array, but the array which is having only zeros. How many zeros I want to be generate? Just 8 zeros. Then we just give you 8 here. Okay. But this is the same zeros. I want to go with the two-dimensional 3 comma 4. I just give the shape as the input for the zeros. Then it will go for the generating the 3 rows of 4 columns. Okay, meanwhile we can generating the 3-dimensional also, 3 comma 2 comma 4, which means 3 matrix for each row, which we have the there is a for each matrix which we have the 2 rows, for each row which we have the 4 columns, right? This is the way we can able to go for the generating the zero matrix. Okay, but here the each and every zero, it is a float type, right? So internal object data, I want to be hold it as a integer type format. Then we just use the d type is the int. Okay, here we can mention d type also. Okay, d type equal to integer. Then it was generating the array matrix with a integer type of data in this particular array. I hope you clear, right? For example, it could be the complex. Then the elements inside of it, it's a complex type. Each and every element in this particular array, which is the complex type. I hope you clear. So this is the way you can able to go for generating the zero matrix as well. Any questions, guys? I'm just waiting for your confirmation. If you have any question, please let me know. I would like to try to answer your questions.
No questions.
Okay, that's great. Now, access a specific row or column in 2 dimensions. This is a pretty cool and it's a mostly used thing actually. For example, you have some kind of data. Okay, so we have some kind of array and you want to be access some rows or we want to access some columns. Okay, then we can do it. For example, before we do this thing, I can go ahead with a small example so we can easily. Okay, so let me go for generating the one array. Okay, so for example, if I'm giving the a array, then which is it is printing the entire array, right? But now I would like to go for the print the only first row. Then we just give you AR of 0, then which is giving the first row. Okay, so this is the row which is printing. This is the row which is printing, right? For example, I want to go for the printing the second row. Okay, clear or not? So this is the way we can able to go for printing the rows wise. Now we can look this one. We can look this one. Here we have an one array, but what we are mentioning here, it's a row comma colon you mention. So that time which is accessing the second row, the entire second row we are going to be accessing something, this one only. If I give you a 0, then what happens? See, so it's a indexing. So this array indexing. So for example, I would like to go for the accessing the first row of the first column I want access 0 comma, so 0 of 0, then which is accessing the 11, right? So that means this is the 11 which we are accessing. Now I would like to go for accessing the first row, that means 0 row of the first column. That means again 11 only we are accessing, because of second column we have the 11 only. Okay, first row second column, and now first row third column. So usually the indexing which is started with 0, 0 means it's a first. Okay, the third column number is, the third column position is 2, so that means which is printing the 9. So this is the way each and every element, okay, with row wise, with column wise we can access. Is it clear? This is array indexing. This is what? Array indexing. So array indexing means first row. If I'm giving the 0, then we're accessing the entire row. If I'm giving the 1, then we are accessing the entire second row actually. For example, you want access only one specific row and one specific column element, then we just give you a position of row and position of column, then which is exactly accessing that specific number only, right? Now, so here what I'm doing here, you just observe here. So we are printing the entire row with the help of this particular print function. Now here I mentioned the 1 comma colon, which means second row. 1 means second. So second row of all columns we are accessing, so that this is entire row we are printing over here. Okay, now might be you thinking I want to go for accessing the a column and data. So if I mention the colon comma in the sense all the rows of the, so here you mention the column name, so column number, the column position, the column position 2, this is the 0 position, this is 1 position, this is 2 position, right? So what are the elements are there in the column 2, that all rows we can access? So in the row 1 we have the 9, in the column 2 of the row 2 we have the 2, so that we are going to be accessing the 9 and 2 as a element, as output for this particular thing. I hope you clear how we can access the elements from the array, either single row or single column or specific element. I hope you clear, right? Any questions, guys? Any questions?
So let's say if I want to find like there are like n elements in one array, and then so basically, yeah, to round it up, do the arrays support like functions like I'll write a function to find n-1 character which is having like n, or without position indexing, can we just like find like, okay, I need like a variable between 15th or 17th positional argument, and then if it's having like 25 elements in the array,
That's
can
also
we
do that. For that one we can use the count. Okay, count underscore non-zero is a function is there. Okay, so
okay,
that's everything we can do actually. Okay, but thing is that that's the only thing is that we have to be go for research on the Google, and we will get some kind of document, and then we can apply it. That's not a big deal. If something is not there, we have to go for apply the functions wise again. Okay,
okay, cool,
if the logic is already implemented, we can use it. If the logic is not already implemented, then it's not possible. Okay, then that time we have to implement our own logic. For that one, you already know the concepts of the Python, then we can implement it, right?
okay,
So if you don't know about Python, then it could be the problem for you for implementing
okay,
your own logic. You already know the Python, right? If something functionality is not there, then we can easily implement it. That's not a big deal.
okay,
But usually, if some functionality is already implemented, whatever the query, you can Google it, and you will be getting the lot of notes and lot of okay, snapshot, and we can go ahead and we can access and we can execute it. That's not a big deal. Okay, but
okay,
it's a rare cases.
okay,
But don't try to be remember each and every function. That's how I'm requesting that.
okay. Is there any other resource apart from Google or Stack
See,
Overflow?
see the default. It's a documentation which is available in Python itself. Okay, you just simply help of okay, you just give you the np then or numpy, which is giving the entire document. It's not a small thing, it's a big thing actually. Okay, you just simply go ahead and look for this one, which is giving the entire document. And if you have an patience, then you just go and read this entire thing. In a one day, you be definitely mad. Okay.
Okay. No, yeah. No, I was asking like
See, even I'm
there is
rotating, it's not even ending.
stopping. Yeah.
My finger is paining actually.
Okay, cool. Yeah, never mind. Yeah.
Not even ending. See, brother. See, too much, right? People are crazy. They're implemented the crazy things. So we are lazy fellows, so we should follow it.
Cool. Yeah.
See, see, it's not even ending. So how many things we can remember? I hope you understood. It's a very thing. So we don't have any option. We just try to go for use the Google. That's the best idea. Okay. Instead of reading this entire document. So if you want to get it anything in a short term, okay, then we just use the Google only. Okay. Clear, right?
Yeah, clear.
Yep. Now, oh, I directly went for the last thing. Okay. Okay. Yeah. Hmm. Only indexing is a little confused, okay, thing, but rest of the things you can easily understand. Okay. Now, you already know that how we can able to find the shape. Then we just use the shape attribute, then we can access it. So here, 0, comma, colon, comma, 1. What does mean that? 0 means it's a 0 matrix. Okay. In this particular matrix. Colon means all the rows. Okay. So 0 matrix of the all the rows of the column number 1. So this is column 0, this is column 1, right? The column 1 we have the elements are 11 and 0, so that we are getting output is 11 and 0. I hope you understood, right? This is the way we can able to go for the, so we can use the indexing in a different formation. But again, so practicing only will remember, guys. Okay, but you don't need to practice. It's a basic things, but you don't need to practice actually. Okay.
So arrays are always like row based, and
It's
it's if
rows
you
and columns, rows and columns, but it's maybe one dimensional, two dimensional, three dimensional, four dimensional. That's the only
but
thing.
if you need
You're
to speak a
yes.
specific column, you
Hmm.
can use say a column and then just like go
Yes.
from there. Okay.
Yes. Now, iterate overall all elements. For example, I want to be access each and every element from the array. For example, my array is it's a two-dimensional array. Okay. For example, this is my two-dimensional array. If I'm using the for function for loop, then which is accessing the entire row. If I'm not using this id itr function, then what happened we'll see now. Okay. The difference between the idr function and without idr function we'll see now. Okay. You might be understood. If I'm not using, then what happens? So I'm not using the id itr, just I'm just giving the array as an element this time, which is just printing the rows wise. Okay, so this is the for loop which is just repeated only two times. Why? Because of this is my array which is just a two-dimensional array, and we have only two rows, so that it's a two times is repeated. For first time which is accessing the first row, for second time which is accessing the second row actually. Now when I'm using the id itr, which is not accessing the element, it's not accessing the rows wise, which is accessing the element wise. Okay, so here in this particular array I have the two-dimensional matrix. There are 8 elements are there. These 8 elements which is accessing element by element, so that this is iditr, sorry, nditr is the function which is accessing the element wise from this particular array, so that it's a repeated 8 times. For 8 times, first time first element, second time second element, third time third element. This is the way it will be go for end of it. Clear? So that is the difference between the without nditr and with nditr in a for loop. Clear, right? Simply what we are doing, flattening. If we have the n dimensional data, that n dimensional data we are converting into one dimensional. That is the only logic of it. I hope you clear. Now we can copy and we can duplicate. For example, if we have one particular matrix, that all elements I would like to copy and I want to be storing into the another variable, that we will do it. For example, here I have the one array and this is my two-dimensional array, and I'm copying these elements. I'm copying these elements and I'm holding into one particular array or one particular name, and I'm copying this all elements and I'm storing into the another variable. This time, now what I'm doing actually, my original matrix, I was trying to be modified. What I'm trying to modify in a row 1, column number 2, I want to be modified as the 13. That means this is my row 1. In the row 1, column number 2, right? This is my column number 2. So previously it's a 6. This is the 6 which is replaced with 13. So when I replace 6 by 13, what happens in B and what happens in A? We'll look for that one. So A is modified as the 13, but B is not modified because of A namespace is different and A referencing memory location is different, and B referencing memory location is different. If you modify the one which is not affected for the second one when you're copying the data, okay, this kind of copy we are calling it a shallow copy. It's an interview question. What is the difference between the shallow copy and deep copy? Shallow copy means, so both the variables, so one particular variable, the data of one particular variable we are copying and we are storing into the another variable. But if you modifying the original data, or once if you modifying the present data which is not affected for the both, that kind of thing we are calling it say shallow copy. For example, same thing, now what we can use, I can use the assignment operator. When I am using the A, I'm assigning to the B. This time the memory location of A and the memory location of B, if both are same, if you changing the A, that effect will be happening B as well. So that if you change the A, instead of the 6, if you use 13, then that effect will be happening in B as well. That's the difference between the copy and assignment operator. Any questions regarding about these two things? Any questions, guys?
No.
No, right? So you might be thinking why Anjana is explaining this much of thing, right? You know what? So usually the data which is storing into the different files, okay? This is, for example, file 1, JSON file format, or else CSV file format, okay? Or else Excel file format, or else it may be different file formats. This all file format of data we can access, or we can create the data frame with help of the pandas. So pandas is the one of the library that I can explain you. But once if you're creating the data frame, this is the data frame which is a tabular format. So usually this is the pandas, it may connected with multiple file formats, and after you creating the data frame, then we can able to go for do some kind of numerical operations with help of the NumPy. If the data is the n-dimensional array, then only we can able to do the machine learning algorithms or ML algorithms. If you want to do any kind of machine learning and deep learning on your data, on your raw data, which is not possible directly, so that what we can do, first we can connect it with multiple data sources and access that particular data, and then we can do converting into the numerical Python or n-dimensional data. Then only your machine learning algorithms and deep learning algorithms can be work, so that we can create the model. Otherwise, which is not possible. So guys, before we are applying the machine learning and deep learning, make sure that the data, it should be numerical Python. The data should be n-dimensional array, so that your machine learning and deep learning can be work. Otherwise, it's not. So that numerical Python is pretty important before we are stepping into machine learning and deep learning. Clear? Clear or not?
Here.
Yes. But by the time of try to be do actually. So for example, when you're working with a real time, okay, you want to copy one particular data to the another variable, try to be use the copy. The reason is that if I'm using the assignment operator, if you changing the new one, it may be affected for the old one also. So if you want to access the old one data, it's not possible. Why we are using assignment operator? Because of you want to copy some existing data, right? That existing data, it may be help you in future. But when you are using the assignment operator, if you modifying the new one, it affected for the old one also. That time both data can be affected. It's not possible accessing the old data. So that try to be use the copy method instead of using the assignment. That is the recommendable. Clear? Clear or not?
Here.
Yep. So stack array in the sense we can concatenate the two arrays. For example, here I have the two-dimensional data. Here I have the two-dimensional data, and here also I have the two-dimensional data. So here I want to make it these two arrays in a vertical stacking. Vertical stacking in the sense array by array. So first, or else matrix by matrix. This is my matrix 1, or this is my matrix 2. These two matrices are concatenated with V stack. That means vertical stacking. Stacking means concatenation. H stack means what? Horizontal concatenation. So this is the four elements, this four elements, and this four elements. It can be as a one row only. Okay, I hope you understood what exactly the difference between the H stack and V stack. Okay, so see 2 1 and 2 1. So this is my row 1. So this row 1 can be here the element. So combination of the matrix 1 row 1, matrix 2 row 1 can be defined as the one row, and row 2 of the matrix 1, row 2 of the matrix 2 can be combined as the main one row actually. So this is the H stack is doing usually. H stack is one after one, V stack is one by one. Now we can do some kind of dot matrix. So for example, these are the two or the scalar, so that if I'm applying the dot, so 3 into 4, it's a 12 actually. So it's a dot product, nothing but. Now this is my row 1, this is my this is my matrix 1, or this is my matrix 2. Now if I'm applying the dot, then what I can do, this element and this element. Okay, so 2 into 3, how much? 6. 6 plus 4,
10,
10 plus 35,
45,
45 plus 22.
45 plus 32, 77.
So simply what we can do, this is my row matrix. Okay, so when I want to do that dot matrix, so make it, this is my column matrix. Let me consider this is my column matrix. Okay, now we just apply the, this is the row, it can be multiplied with this particular column. So 2 into 3 6, and 1 into 4 4, and 5 into 7 35, 4 into 8 32. When you combining, when you're doing the sum of it, then you will be getting the 77. Okay, now for example, we have the 2 by 2 matrix. So we have the 2 by 2 matrix. Then what happens? This is my matrix 1, and this is my matrix 2. Okay, this is my matrix 1 2 1, and this is my 5 4. So my row 2 is 5 4, my matrix 2 of the row 1 is 3 4, and my matrix 2 of the row 2 is, it's a 7 8. This time I can do the dot matrix. Then this is the first row and this is the first column, can be creating the one new element. Okay, 2 into 3, how much? It's a 6. 6 into 6 plus 1 into 7, 7, right? 6 plus 7, how much? 13. So this is the element has generated. Now I want this particular element. If you want this element, you just use the row and you can use this particular column. 2 into 4 8, 1 into 8, it's 8, right? 8 plus 8, it's a 16. Okay, now I want to access this particular column. Then row matrix of the row 1 and matrix 2 of the column 1 can be creating the new matrix of row 1 and column 1. So 5 into 3, 5 into 3, how much? 15, right? 7 into 4, how much? 28, right? 15 plus 7, 28, how much? 43. Now I want to generating the fourth element. Then what we can do, you just go through this particular row and you just go through this particular column. 5 into 4 20, and 4 into 8 32. So 20 into 32, it's a 52, right? That's it. So this is the dot matrix. If you want to do the dot matrix on the column, then we can use the dot method. So cross product, what is mean that cross product? So this and this one. So 2 into 7, 14. 14 minus 3 into 1, 14 minus 1, it's 11. So this is the cross product. Okay, So cross product, which is multiplying the cross and subtraction that one. Now, for example, there we have it's a one-dimensional matrix. It's fine. Here also we have one-dimensional matrix, right? So how you're getting this one? Can anybody tell me how you're getting this one? So if you want it, see there is a three rows and there is a three columns, right? So now if you want it, this element, you have to be close this one. Then what we can do, multiplication of this and multiplication of this two. 7 into 8. 7 into 8, how much? 56. 4 into 9, 36. 56 minus 36, 20. Now this is fine. Now if you wanted the second element, then we can cross multiplication of the, this is 4, then this is 3, and this is 8. We just hide this 7 and 9. Next, 4 into 8, how much? It's a 16, right? And 4 into 3, how much? It's a 12. We got here is a 4, but as a result, how much we are getting? Minus 4, right? The reason is that the first one is the multiplication of the plus, and the second one is second result we have to multiply with minus. Third result and the third row or third column we have to multiply with plus, and then it's a minus, then plus, and then minus. It's go on actually. Okay. See, which means that so here 16 minus 14 is 4, and 4 minus into 4, it's a minus 4. Just 1 minute, guys. I'm getting a call. Okay. Yep. Have to clear all, right? Yes. I hope you understood, right? Why we are getting the minus 4. For example, if you wanted third element, then we have to hide the third column. Then 2 into 9, 18. 7 into 3, it's a 21. 19 minus 21. 19 minus 21 or 20? Sorry, 18 minus 21, how much?
Minus 3.
Minus 3. So you are getting the minus 3. So this is the cross product, guys. Okay. Now you're going to be adding the constant to our existing matrix. So here I have a shape of the matrix is, it's a 2 by 4. This is my matrix. It's a 0, 2, 4, and 6. Now what I'm doing, so I just addition with the 3. That means each and every element it can be addition with the 3. So 0 plus 3 is a 3. 2 into 2 plus 3 it's a 5, and 4 plus 5 it's a 4 plus 3 it's a 7, and 6 plus 3 it's a 9. So this is the way each and every element it can be addition with the 3. Now we can try to multiply with the 3. That means each and every element it can be multiplied with 3. This is a scalar with a matrix. We can do all kind of operations, all kind of arithmetic operations on our matrix with the scalar numbers. Okay, like division, modulus, everything we can do it. I hope you clear, right? This is the arithmetic operations we are performing on the matrix with scalar numbers. And this is power of each and every element. So here I just want to find the square root of each and every element. For example, we have a list A and I have a matrix is square root. If I'm giving the list, each and every element it can do the square root. Square root of 4, it's a 2, right? Square root of 16, how much? It's a 4, right? Square root of 3, how much? It's a 9, right? Square root of 1, it's a 1. Square root of 25, it's a 5. Square root of 49, it's a 7. So if you want to apply the square root of each and every element from this particular list, we just use the square root function. Okay. So even if we have the complex numbers also, that complex numbers also we can apply the square root function. So why we are getting this one, don't ask me, because of it's a mathematical intuition. So we have to go for understanding the how we can find the square root of the complex numbers. We will be getting a lot of resources. Now if you have the minus 4, if you have the minus number, if I am applying the square root, you won't get the output. It will be giving the none actually, but you won't get like a complex number. You will be getting something like, none. Okay. So in case of numerical Python, if you are applying the square root function, okay, you will get the none. So here you can able to go for find the maximum element. Rand in the sense we are going to be generating the random elements. So maximum 0 to 9 only. For this 0 to 9 elements, we are arranging in 4 rows and 5 columns. From this particular array, we are going to be finding the maximum element. From this particular array, from this particular entire matrix, which could be the maximum element? 9, right? 9 or not? So if we have the some fractional data, so if you are going to finding the max value, then which is giving the max element only, but it is giving some instead of the 7, which is giving some more than fractions. So here we have only 3 and 7 and 8. After the point we have only 8 decimal points. Maybe here we have the 15 or some 20. This is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So after the point there are 16 fractions are there, but here we have only 7 factors, right? 7 or 8. Okay, it can be 16 factors. Usually it's a 16 fractions, but here we have only 8, right? So that it is adding, it's removing the 7 and replacing with this particular number. Okay, why we are giving this number in the sense we don't have any specific idea. It can be giving some random anything. Okay, okay, that's fine. Now you would like to go for finding the arguments wise access. If I'm giving the access equal to 0, if I'm giving the access equal to 0, what is mean that? What is mean that for this particular entire column, what could be the max element? 7, right? From this particular entire column, what could be the max element? 3, right? From this particular entire column, what could be the max element? 8, right? From this particular entire column, what could be the max element? 9, right? From this particular entire column, what could be the max element? 9, right? So that's the meaning of the access equal to 0. Access means column, entire column, okay, or one specific column, columns wise. Okay, if I'm giving the access equal to 1, which means row wise, from this particular row, what could be the max element? 9. From this column, what could be the max element? 9. From this column, what could be the max element? 9. From this column, what could be the max element? 8. So that's the meaning of it. So here a max, which is giving the access max. Previously entire element. So you can able to go for finding the sum of all elements with a simple sum function. Meanwhile, we can able to go for finding the sum of access equal to 0. When I'm giving the access equal to 0, what is exactly doing actually? Access equal to 0 in the sense, this is the two things can be summing. 4 plus 3, 7. 5 plus 7, it's a 12. That's the meaning of access equal to 0. Okay, we are doing the sum, but in a columns wise. If I'm giving the access equal to 1, rows wise, which is doing the sum. 4 plus 5, 9. 7 plus 7, 3 plus 7, it's a 10. Clear? Now we can do it initial. What does mean that initial? Can anyone try to be observe this particular answer and tell me what happening here? What exactly happening here? Can anyone explain here? Nothing, guys. We can do the sum of it. How much we are getting? 4 plus 5, 9. 9 plus 3. 9 plus 3, how much? 12. 12 plus 7. 19.
19.
That 19 we are going to be addition with 52. So that we are getting the 71. Right or not? That is the meaning of initial. So by default it's a 0. 0 plus this entire thing, it's a 19 only we are getting. But here this initial, if you're specifying with some number, that it can be adding with your sum of original matrix. Is it clear or not? Why we are getting the 71? This is the 52, which is addition with the sum of this all elements. That is the meaning of it. Sunny, is it clear?
Yes.
So we can converting the array to list. For that one, we can have a function is toList. So array object dot toList, we can use it. Then it can be converting into the list data type. So this is my list data type. This is actually array. this is array which is converting into list. So meanwhile, if we have a list that we can converting into the array with help of the array function. Okay, so here we can apply the all, and all means if all elements are true, then the resultant can be true. For example, all are so one element which is false. So here these are the two elements are true, but these two elements are false, right? If at least one element is false, then entire thing it could be the false only. But here if I'm mentioning the access equal to 1, access equal to 1 means what, guys? Access equal to 1 in the sense this is row. So these two rows are the true, so that this entire thing it could be true. But this is the row, one element is false, so that which is false. This is the row also having the false, one element is false, so that it's giving the false. So this we are going to be finding all elements are true in a row wise, then we can use the access equal to 1. So wherever we can see the access equal to 1, which means rows wise, wherever we can see the access equal to 0, we can considering the column. Clear? So that's about NumPy, guys. Actually, if you want to discuss NumPy, a lot of concepts are there, but you don't need to worry about that all concepts. You know, whenever you wanted, we just to go and use a lot of online resources. It can be available. Okay. So if you know the numerical Python, we can easily handle the statistics class in a practically. Okay, so if just if everything, if I'm explaining in a notepad or whiteboard in a mathematical notation, you might be getting boring, something like maths. So that I have to explain the numerical Python in upcoming session. If I'm getting if I want to be execute in a Python that particular stats, then I can go ahead and use this particular numerical Python. Clear, right? Okay, that's for today's class, guys. I hope everyone is clear, and we'll catch up tomorrow for continuation of the stats class. Bye. Take care.
Thank you.
Thank you.
Srijan, you and Ashmita, you both are come for today's tomorrow morning session as well. I mean,
Okay.
I'm in IST, so that you can follow my timings. Okay.
Okay.
Yeah. As,
Okay.
you came for Python, in the same way you can come. Today we entered the Python session, right? In the same way you can come for today's class as well. Okay. Bye guys. See you. Take care.